Every decision you have ever made might have spawned an entirely new world. The idea of parallel universes is not just science fiction. It is a thrilling frontier of modern science and philosophy that redefines reality itself. By the end of this exploration, you will have journeyed through 25 of the most shocking theories that physicists and thinkers have ever proposed. We will venture from the bizarre rules of quantum mechanics, where cats are both alive and dead, to cosmic myths of colliding dimensions and bubbles of space. What we uncover will challenge everything you think you know about existence. Are you ready to question the very nature of your own reality? Our journey begins with a single cat in a sealed box. This feline is not just a pet, but the star of a famous thought experiment designed to highlight the strangeness of the quantum world. Inside that box, a quantum event like the decay of a single radioactive atom is linked to a vial of poison. According to the traditional rules of quantum mechanics, until someone opens the box and looks, that atom exists in a blurred state of both decayed and not decayed. Therefore, the cat is, in a very real sense, both alive and dead at the same time. It is a powerful paradox that has puzzled scientists for generations. But one physicist, Hugh Everett, offered a solution so radical it redefined reality itself. He called it the many worlds interpretation. Everett proposed that the paradox is only a paradox if you believe there is only one universe. His theory states that at the moment of that quantum event, reality does not choose a single outcome. Instead, it splits. One entire universe continues forward where the atom decayed and the cat did not survive. Another completely separate universe branches off where the atom remains stable and the cat is perfectly fine. Both outcomes are 100% real. They just happen in different, now disconnected, layers of existence. This is not a metaphor. In Everett's view, every single quantum possibility is actualized somewhere. Every time an electron spins one way or another, every time a photon could take one path or a million, the cosmos forks. The implications are staggering in their scale. It means that right now, as you listen to this, your reality is constantly dividing. For every choice, for every random quantum fluctuation in your brain, in the air, in the stars, new universes are being born. An infinite multiverse blooms from every nanosecond, containing every possible version of history, every road not taken, and every conceivable variation of you. The cat is not both alive and dead here. It is alive in one world and dead in another, and both of those worlds are equally real. This is the first and perhaps most profound shock to our classical understanding, a universe where everything that can happen does happen somewhere. But the branching of worlds may not begin with quantum choices. It could be baked into the very fabric of space and time from the very first instant. To understand this, we must rewind to the beginning of everything. The prevailing theory of our cosmic origin is the Big Bang, but it has a problem. The universe we see is too uniform, too smooth across vast distances that light has not had time to connect. To solve this, physicist Alan Guth proposed a monumental idea called cosmic inflation. He suggested that in the first fleeting fraction of a second after creation, space itself underwent a period of hyper-fast exponential expansion, stretching far faster than the speed of light. This smoothed everything out, creating the even cosmic canvas we observe. But here's where the theory takes a shocking turn. Guth and others realized this inflationary process may not have been a one-time event that started and stopped everywhere. Instead, think of it like a pot of water beginning to boil. In most models, inflation is a state that is inherently unstable. It can end in a region, allowing for a stable universe like ours to form, but the driving force behind inflation itself may be eternal. This means that while inflation ended in our local region of reality, giving rise to our Big Bang and everything in it, it continues unabated in the wider, unobservable expanse beyond. Wherever it continues, more space is furiously created, and within that new space, random quantum fluctuations can cause new pockets or bubbles where inflation locally stops. Each of these bubbles becomes its own separate universe, pinched off from the inflating background. Our entire observable cosmos, with all its hundreds of billions of galaxies, is just one such bubble in an infinite, ever-growing froth of cosmic foam. This is the inflationary multiverse, and the properties of each bubble are not identical. The random quantum jitter that causes a bubble to form can also set its fundamental physical laws and constants. In one bubble, the strength of gravity might be 1,000 times stronger, making stars burn out in an instant. In another, the nuclear forces might be too weak to ever form atoms. We happen to live in a bubble where the numbers are just right for galaxies, planets, and life to emerge. This idea offers a staggering perspective. Our universe is not unique. It is one possibility in an endless ocean of other realities, each with its own version of physics, its own history, and perhaps its own forms of unimaginable existence. The multiverse is not just a consequence of quantum mechanics, but a fundamental architectural feature of reality itself, written into the first moments of creation. Yet even this cosmic foam of bubble universes may exist within a far stranger structure. The third theory takes us to the cutting edge of theoretical physics, to a framework that seeks to unify all forces in nature, string theory. Its most advanced version, known as M-theory, proposes a reality of 11 dimensions. We experience only 3 of space and 1 of time. Where are the others? They are curled up, compacted into spaces so infinitesimally small our instruments cannot detect them. But M-theory offers a truly shocking vision for where our universe sits within this higher dimensional space. Imagine our entire cosmos with all its galaxies and stars, not as a boundless expanse, but as a single 3-dimensional sheet or membrane floating in a higher dimensional realm. Physicists call this sheet a brane, short for membrane. Our reality is confined to this brane like a painting on a canvas. We are stuck to it. All the matter we know, all the light we see, every particle that makes up you and me is like ink on that canvas, unable to leave the surface. But here is the twist: in this higher dimensional bulk, there could be other branes, other entire universes with their own stars, their own laws, floating parallel to our own. They could be mere millimeters away from us, but that distance is not measured in our 3 dimensions. It is a separation in a 4th, 5th, or 6th spatial dimension that we are utterly blind to. Another universe could be right next to you in a direction you cannot point to. This brane multiverse idea solves a profound mystery. Why is gravity so unimaginably weak compared to the other fundamental forces? A small magnet can lift a paperclip, defeating the gravitational pull of the entire Earth. In the brane model, one possibility is that gravity is the only force not stuck to our brane. It can leak out or dilute itself into the higher dimensional bulk. What we feel as gravity is just a tiny fraction of its full strength, with the rest spilling into dimensions we cannot access. But the most staggering implication concerns our own origin. Some models suggest that the Big Bang itself was not a singular point of creation, but a violent cosmic accident. A collision in the silent darkness of the bulk, our brane and another parallel brane could have drifted on a collision course. When they smashed together, the immense energy of that impact ignited the rapid expansion and searing heat we now call the Big Bang. Our universe in this view was born from a shattering encounter with another reality. We are the afterglow of a dimensional car crash, and the echoes of that collision might still be rippling through the cosmos today. The idea of a single definitive beginning for all things is deeply unsettling, yet the cyclic model offers a different kind of eternity, one not of a lonely bubble, but of a relentless cosmic heartbeat. Proposed by physicists Paul Steinhardt and Neil Chirac, this vision builds upon the brane multiverse but weaves it into a story of perpetual rebirth. In their theory, our 3-dimensional universe is one of 2 parallel branes, floating like immense, silent sheets in a higher dimensional space. The other brane is a shadow universe, a ghostly parallel reality that may contain its own forms of matter and energy, forever separated from us by a microscopic gap in an unseen dimension. These 2 worlds are not strangers, however. They are bound together by gravity, engaged in an eternal, slow-motion dance. Over trillions upon trillions of years, they are drawn together by that invisible force, moving closer and closer through the dark bulk. The climax of this cosmic approach is not a gentle merging, but a cataclysmic collision. When the 2 branes finally slam into one another, the impact is not destruction in the way we think of it. It is a transformation. The immense kinetic energy of the collision floods both universes with a searing, dense fire of raw energy and matter. This fireball is, in every meaningful way, a new Big Bang. It wipes the slate of each universe nearly clean, vaporizing old galaxies, extinguishing old stars and resetting the cosmic clock to a new beginning. From that fiery rebirth, the branes are flung apart, beginning a new epoch of expansion and cooling. Galaxies form, stars ignite, life may arise, all while the branes drift slowly apart on their outward journey. But gravity never lets go. Eventually, the expansion slows, halts, and reverses. The dance begins again. The two universes are pulled back toward their inevitable, world-shattering embrace. This cycle of collision, rebirth, expansion, and return is not a one-time event. According to the theory, it has happened an infinite number of times in the past, and it will continue for an infinite number of times into the future. There was no first cycle, and there will be no last. The shocking implication here is that time itself is not a straight line from a singular beginning to a cold end. It is a vast, endless circle. Our entire history, from the formation of the first hydrogen atom to the rise of civilizations on distant worlds, is just one act in a play that has been performed countless times before. Every galaxy, every planet, every person has existed in some form in prior cycles and will exist again in cycles to come, though never in exactly the same arrangement. The universe is not born from nothing. It is reborn from the ashes of its previous self, locked in an eternal, rhythmic dance with its shadow twin. The sheer scale of these cosmic collisions and eternal cycles is almost impossible to grasp. Yet there is a theory that pushes the boundaries of what we consider a universe even further, into the pure, abstract realm of numbers and equations. This is the mathematical universe hypothesis proposed by physicist Max Tegmark. It begins with a simple yet deeply unsettling observation. Our physical world, from the orbit of planets to the spin of an electron, is described with uncanny precision by mathematics. The laws of physics are written in its language. Tegmark takes this observation to its ultimate, logical extreme. What if this isn't a description, but an identity? What if our universe isn't just described by a mathematical structure, it is that mathematical structure? Think of it like a video game. The world you explore on screen isn't made of silicon and electricity in the way your character experiences it. It is, at its core, a set of algorithms and data structures running on a computer. In this view, we are not characters in a physical world that happens to follow math. We are patterns, complex self-aware computations within a giant, self-consistent mathematical object. From this core idea comes the shocking conclusion. If our reality is a mathematical structure, then why should it be the only one? Tegmark proposes the ultimate ensemble, often called the Level 4 multiverse. It states that every single mathematical structure that is logically consistent, that does not contain internal contradictions, exists as a physical reality somewhere. It is a staggering declaration. Any universe you can define with a coherent set of mathematical rules does not just exist as a thought experiment, it exists, period. This includes universes with 5 stable spatial dimensions, where geometry is a playground we cannot visualize. It includes realities where the fundamental constant pi, the ratio of a circle's circumference to its diameter, equals exactly 3, creating a warped and alien geometry. It even encompasses realities built on entirely different systems of logic, where concepts like true and false or cause and effect operate in ways our brains are literally incapable of comprehending. The multiverse in this view is not a collection of similar physical bubbles or branes. It is a vast, silent library containing every possible book of mathematical consistency. Our cosmos, with its specific laws and constants, is just one volume on an infinite shelf. Somewhere, there is a universe where gravity is repulsive. Somewhere else, a reality exists that is nothing but an endless, perfect fractal. The mathematical universe hypothesis transforms the multiverse from a physical concept into a Platonic one. It suggests that all possible structures are not created in some cosmic inflation, but simply are in a timeless, abstract sense. We find ourselves within one particular structure, and we call its rules physics. But the true nature of reality may be nothing more and nothing less than mathematics itself. The idea that mathematics might be the ultimate reality is a dizzying abstraction, but one theory brings the multiverse crashing back into the most personal space imaginable, your own mortality. This is the thought experiment of quantum immortality, a direct and deeply unsettling consequence of the many worlds interpretation we explored earlier. It asks a simple, terrifying question: what does death feel like in a universe that splits at every possibility? To explore this, we must construct a grim scenario. Imagine a person, let us call them Alex, who agrees to participate in a macabre experiment. Instead of a traditional six-shooter, this version of Russian roulette uses a quantum trigger. The device is linked to a radioactive source. In any given second, there is a precise 50% chance a single atom will decay. If it decays, the gun fires. If it does not, it merely clicks. Alex places the device against their temple and pulls the trigger. According to classical physics, this is a game of chance with tragic potential. But in the many worlds universe, the outcome is different. At the moment the trigger is pulled, reality splits. In one branch, the atom decays, the gun fires, and Alex's story ends. In another perfectly real branch, the atom remains stable, the gun clicks, and Alex lives. Now here is the crucial point. From a first-person perspective, from the viewpoint of the conscious being we call Alex, which branch do they experience? The theory suggests they can only experience a branch in which they are alive and conscious to have an experience. In the branch where the gun fires, Alex's consciousness ceases instantly. There is no one there to witness that outcome, but in the branch where the gun clicks, Alex is very much alive, feeling a surge of adrenaline and relief. They have just survived. Now suppose the experiment is repeated. Again, the universe splits. In some branches, the second trigger pull is fatal. In others, Alex survives again. From the internal viewpoint of Alex's continuing consciousness, they will only ever find themselves in the sequences of branches where they do not die. They will always hear the click, they will always feel the relief. No matter how many times the experiment is run, from Alex's subjective reality, they appear to be miraculously, impossibly lucky. This creates a bizarre and shocking subjective illusion. To Alex, it might seem as though they are immortal. They could theoretically play this quantum game 1,000 times, 1,000,000 times, and from their first-person perspective, they would always be among the survivors. The chilling notion is that you might never, ever experience your own death in any universe you can be aware of. Your conscious experience would seem to hopscotch eternally through the branching paths of the multiverse, always landing in a timeline where you persist. Of course, this is a thought experiment, a logical extreme. It does not mean you cannot be injured or grow old or face mortal danger. It simply suggests that the final moment of cessation, the experience of death itself, may be something your conscious self never encounters. You would simply cease to be in the timelines where it happens, while continuing on in others. This transforms death from a single definitive end into a strange, branching disappearance from your own story. It is a concept that blurs the line between profound comfort and existential terror, forcing us to ask what it truly means for a self to exist and end in a reality of infinite possibilities. But this subjective immortality rests on a reality that may itself be an illusion. The seventh theory asks a question that has haunted philosophers for millennia and now intrigues modern technologists. What if nothing is real, not in the sense of a dream, but in the cold, logical sense of a computer simulation? This is the simulation hypothesis, and its implications for parallel universes are staggering. The argument begins with a simple projection of technological progress. If any civilization in the cosmos survives long enough to reach a post-human stage of development, its computing power would be godlike. It could then choose to run incredibly detailed simulations of its own past or of entirely fictional worlds. These would be ancestor simulations, so perfect that the conscious beings within them would believe their reality is fundamental. Now follow the logic. If even one advanced civilization runs many such simulations, the number of simulated minds would quickly dwarf the number of original, biological minds in the base reality. Therefore, if you are a conscious being, you are statistically far more likely to be one of the countless simulated minds than one of the rare original ones. The shocking statistical conclusion is that we are almost certainly living inside a simulation right now. This is where the theory explodes into a factory for parallel worlds. Think of the creators of our simulation not as gods, but as cosmic programmers. They would not run just one simulation of Earth's history. They would run millions, perhaps billions. Each run would be a separate instance, a new file with its own unique seed number. They might tweak the parameters slightly to see what happens. What if the asteroid never hit the dinosaurs? What if a different inventor created the light bulb? What if you took that other job? In this model, every single what if is not a lost possibility. It is an active running simulation. Each one is a fully realized parallel universe existing on some unfathomable server in a higher reality. Your life in all its specific detail is one thread of code in one specific simulation run. The version of you that made different choices exists just as vividly in another instance running right next to yours. This transforms the multiverse from a natural phenomenon into an engineered artifact. The branching of worlds is not driven by quantum splits or colliding branes, but by the curiosity of our creators running endless variations on a theme to study history, ethics, or simply for entertainment. The cosmos we observe with its distant galaxies and fundamental constants is not the bedrock of reality. It is the rendered graphics setting, the physics engine chosen for this particular simulation. The eerie fine-tuning of our universe for life is not a cosmic accident, but deliberate design by the programmers. This idea forces a profound shift in perspective. Every person you meet could be a sophisticated artificial intelligence, a non-player character in your personal instance. Your deepest thoughts and feelings are processes running on a substrate you cannot comprehend. And the ultimate parallel universe is the base reality itself, the original world where the simulators reside, a place whose true nature we can only guess at, hidden behind layers of code we perceive as physics. The concept of a simulated reality is a profound shift in perspective, but it still assumes a world built on information. Another theory takes this idea to a cosmic extreme, suggesting that information is not just the basis of reality, but its very limit. This is the holographic principle, and it emerges from the most mysterious objects in the cosmos, black holes. When matter falls into a black hole, it seems to vanish forever, taking all its information with it. This presented a paradox that threatened to unravel physics. The solution, proposed by physicists like Gerard T. Hooft and Leonard Susskind, was revolutionary. They suggested that all the information describing everything within a three-dimensional volume of space is not stored within that volume at all. Instead, it is perfectly encoded like a cosmic blueprint on the two-dimensional boundary that surrounds it, its event horizon. It is akin to a hologram. A standard holographic film is a flat two-dimensional surface of etched patterns, but when you shine a laser through it, it projects a stunning, fully three-dimensional image that seems to have depth and solidity. The holographic principle states our universe operates on the same staggering principle. Every star, every planet, every person in our three-dimensional world might be a fantastically complex projection from a two-dimensional surface at the very edge of the observable cosmos. We are not the solid reality we believe ourselves to be. We are a holographic illusion, a ghostly image projected from a distant, flat screen of fundamental information. Now extend this mind-bending idea to the concept of parallel worlds. If our entire cosmos is a holographic projection from one specific two-dimensional surface, what is to stop other projections from other surfaces? Imagine a vast higher-dimensional object, a cosmic film reel of unimaginable scale. Different regions of this celestial film could encode entirely different sets of information, each one projecting its own unique, self-contained, three-dimensional universe. Our universe would be one holographic movie playing from one section of the film. Right next to it, encoded in a different set of patterns, another universe is being projected with its own galaxies, its own laws of physics, its own versions of history. These parallel realities would not be separate bubbles floating in space. They would be different projections emanating from the same cosmic source, like different television channels broadcasting from the same satellite. They're all equally real, all equally vivid holograms, but they are playing on different adjacent parts of the same ultimate screen. In this view, the multiverse is not a collection of disconnected spheres. It is a multiplex of holographic projections, a gallery of three-dimensional illusions, each one complete and consistent within itself, yet all arising from a flat, two-dimensional code we can never directly perceive. The space between you and your wall, the vast gulfs between galaxies, all of it is an emergent property, a grand mirage, and somewhere on that distant boundary, in a language of physics we're only beginning to decipher, The entire script for our reality and for every other possible reality is eternally written. Yet the hologram we perceive might have a perfect inverted twin. Deep within the equations of quantum field theory, the most precise scientific descriptions we possess, lies a profound and elegant symmetry known as CPT. It is considered sacred, a fundamental rule that the combined operations of charge conjugation, parity reversal, and time reversal must leave the laws of physics unchanged. To understand this, we must break it down. Charge conjugation C swaps every particle with its corresponding antiparticle. An electron becomes a positron, a proton becomes an antiproton. Parity P is like creating a perfect mirror image, flipping all spatial coordinates left to right, up to down, forward to backward. Time reversal T is exactly what it sounds like, running the clock backwards. Individually, these symmetries can be broken. We live in a universe that clearly prefers matter over antimatter, and it has a distinct handedness, a preference for left or right in certain particle interactions. But physicists have found that the combined operation of all three together, CPT, appears to be an unbreakable symmetry of nature. This is not just a mathematical curiosity. It has a staggering implication. If you take our entire universe and apply the full CPT transformation, you would generate a new self-consistent universe that obeys all the same fundamental physical laws. What would that universe look like? It would be a perfect cosmic reflection. In this mirror universe, every particle of matter is replaced with its antimatter counterpart. The very atoms that make up stars and planets will be built from antimatter. Its geometry would be a mirror image of ours. A spiral galaxy that spins clockwise here would spin counterclockwise there. And most shockingly, time itself would flow in reverse from our perspective. A cup shattering on the floor in our world would, from the viewpoint of that universe, be a cup assembling itself from fragments and leaping back onto a table. This is not science fiction. It is a direct mathematical consequence of our most trusted theories. The CPT mirror universe would not be a separate bubble or a distant brane. It could be seen as the other half of a single symmetric reality, a necessary counterpart demanded by the equations. From our vantage point, it would appear to be a universe expanding backward in time from the Big Bang. Imagine if we could somehow peer across this symmetrical divide. An observer there, made of antimatter and experiencing time in reverse, would look at our universe and see the exact same thing, a bizarre antimatter cosmos where time runs backward. Each universe would view the other as the strange inverted one. The truly unsettling question is whether this mirror cosmos is a mathematical abstraction or a physical reality. Some interpretations suggest it must exist to preserve the fundamental symmetry of the vacuum of space itself. It means that for every action we take, every star that ignites, every life that begins, there's an equal and opposite sequence playing out in reverse on the other side of this cosmic looking glass. A universe born from what we would call the far future and collapsing toward what we call the beginning. The idea of a mirrored antimatter universe is a breathtaking symmetry, but it still arises from the equations of our physics. What if the truth is even more radical? What if every story, every daydream, every wild fantasy you have ever had describes a place that is just as physically real as the world you are sitting in right now? This is not a theory of physics, but of pure philosophy, and it is called modal realism, championed by the thinker David Lewis. His argument begins by challenging our most basic assumption about the word possible. We say it is possible you took a different job, or possible that Napoleon won at Waterloo. We treat these as mere ideas, ghostly alternatives that float in the realm of imagination. Lewis turned this completely on its head. He declared that to call something possible is not to describe a figment of our minds, it is to point to a concrete, physical place. In his view, every logically coherent world that can be described exists, not as a simulation, not as a quantum branch, but as a fully realized, spatio-temporally isolated cosmos. These worlds are not somewhere else in our space, they are not distant galaxies, they are entirely separate realities with their own space and their own time, disconnected from ours in every fundamental way. There is no travel between them, no wormhole, no portal. The only connection is a logical one, the fact that we can imagine them. The implications are staggering in their absolute literalness. A world where you are a pirate sailing the Caribbean, a world where the dinosaurs evolved sentience and built cities, a world that is literally a giant wheel of cheese. All of these are out there, right now, as real as the ground beneath your feet. In those worlds, the inhabitants are just as convinced that their reality is the only one. The pirate version of you feels the salt spray, grips the ship's wheel, and has no idea that another version of them is listening to a video about parallel universes. In Lewis's system, every work of fiction becomes a kind of accidental documentary. When you read a novel about hobbits in Middle-earth, you are not just enjoying a made-up tale. You are learning in a limited way about the actual facts of a distant universe. The author, in Lewis's view, did not create that world. They discovered its logical contours through their imagination and reported them to us. This makes modal realism the ultimate multiverse. It contains not just every quantum outcome or every variation of physical laws, but every narrative, every myth, every coherent daydream. The only worlds that do not exist are those that contain logical contradictions, like a round square or a married bachelor. Everything else is fair game and is real. This philosophy forces a brutal but fascinating question. If all these worlds are equally real, what makes our world special? Why is this the actual world? Lewis's answer is simple and humbling. Nothing does. We call it actual only because we are in it. To the pirate version of you, their world is the actual one, and ours is just another possible story. There is no center to reality, no privileged stage. We are not the main character of existence. We are merely one perspective in an infinite library of equally valid realities. This idea stretches the concept of existence to its breaking point, challenging us to accept that the line between the possible and the actual is an illusion, a trick of our parochial point of view. The precision of these cosmic collisions demands a specific and elegant mechanism. Enter the ekpyrotic universe, a refined and startling version of the brane collision model. Its name comes from the ancient Greek word for conflagration or out of fire, and it paints a picture of creation that is both cyclic and profoundly elegant. Imagine again our three-dimensional universe as a vast flat membrane or brane, but in this model, there is a second, identical brane floating parallel to it in a higher dimensional space. These are not crumpled sheets or drifting bubbles. They are perfectly flat and static in the bulk, like two immense panes of glass suspended in a silent void. The space between them is nearly empty, a dark gap containing only a subtle, pervasive energy field. This field acts like a cosmic spring. Over eons, it draws the two parallel worlds together, slowly and inevitably. There is no initial explosion, no singularity of infinite density. Instead, the story of our cosmos begins not with a bang, but with a whisper and then a crash. As the branes approach, quantum fluctuations in the field between them create tiny ripples, seeds of future structure. Then they collide. This is the ekpyrotic moment, the flash of fire. The kinetic energy of the impact is not destructive but creative. It is instantly converted into a searing, dense plasma of particles and radiation that floods both branes. This is our Big Bang, not a beginning from nothing, but a transformation from one state to another. The branes do not stick, they rebound, bouncing apart after the collision, carrying that hot, expanding fire with them. As they separate, the universe we know begins to cool, allowing atoms to form, then stars, then galaxies, all on the surface of our receding brane. The shocking precision of this model lies in its solutions. It naturally explains the smoothness and flatness of our universe. Because the colliding branes were flat and parallel to begin with, the tiny quantum ripples generated during the approach become the blueprint for all cosmic structure, the subtle variations that grew into galaxies. Most profoundly, it eliminates the need for a singularity, a point of infinite density where the laws of physics break down. Our entire history is simply the aftermath of an encounter, the cooling embers of a collision with a silent, parallel world that may be drifting toward us once more for the next cycle of fire and rebirth. But these collisions and cycles all unfold on a grand cosmic scale. There is a theory that brings the engine of creation down to a single, terrifying point of darkness. This is the idea of black hole cosmology, and it suggests that the key to a new universe lies at the heart of ultimate destruction. We know that when a massive star dies, its core can collapse under its own gravity, crushing down to an infinitesimal point called a singularity and wrapping itself in an event horizon from which not even light can escape. This is a black hole, a place where our laws of physics seem to break down. But what if that breakdown is not an end, but a transformation? The provocative theory proposes that the singularity is not a dead end. Instead, it could be a bridge. When matter and energy are crushed to infinite density, the equations of general relativity suggest spacetime becomes infinitely curved. Some physicists speculate that this extreme curvature could act like a cosmic trampoline. Instead of matter being destroyed forever at the singularity, it might experience a bounce. The collapse reverses in an instant, triggering a rapid, explosive expansion. But this expansion would not happen back into our own universe. It would create an entirely new self-contained spacetime, sealed off behind the event horizon of the black hole. In this view, every black hole is not a tomb but a womb. It is a pinched-off region of reality where a new universe is born with its own Big Bang, its own dimensions, and its own laws of physics, forever disconnected from the parent cosmos that spawned it. Now follow this idea to its most shocking conclusion. If black holes in our universe give birth to new universes, then what about our own cosmos? The theory turns its gaze back on us. The Big Bang that began our universe 13.8 billion years ago looks, mathematically, remarkably similar to the formation of a black hole in reverse. An explosion from a point of near infinite density. This leads to a staggering possibility. Our entire universe, with all its hundreds of billions of galaxies, might itself exist inside a black hole. We may be living in the offspring universe of a colossal star that died in a higher dimensional parent reality. That parent universe has its own stars, its own black holes, and each of those black holes contains its own child universe. This creates a fractal multiverse, an endless nesting of realities within realities. Picture a set of Russian matryoshka dolls, where each doll contains a smaller one inside. In this cosmic version, every universe is a doll, and inside it are all the black holes it has ever produced, each one containing a smaller, self-contained universe doll of its own. And our universe is just one doll in an infinite, perhaps eternal, stack. The implications are beautiful and humbling. Every time a star collapses into a black hole in our sky, it may not be a death. It could be the ignition of a new cosmos, a flash of creation hidden behind a veil of absolute darkness. The supermassive black hole at the center of our Milky Way, Sagittarius a star, might not be a monster. It could be a nascent universe, already trillions of years old in its own time, teeming with its own forms of existence we can never see or touch. In this view, the cosmos is not a single story, but an infinite tree of stories, each growing from a seed of darkness in the universe above. The personal survival of a single consciousness through quantum branching is a deeply individual mystery, but it raises a question of terrifying scope. What happens when the survival in question is not of one person, but of an entire species, of all of humanity? This is the quantum suicide extension, a theory that scales the chilling logic of immortality to a cosmic level. We must return to that grim quantum experiment, but with a weapon of planetary scale. Imagine a device, a doomsday machine, triggered by a single quantum event. Perhaps it is a particle detector watching for a rare decay that, if it occurs, will unleash an unstoppable chain reaction, sterilizing the Earth. From an outside, godlike view of the multiverse, the device is activated. At that moment, reality fractures into two primary branches. In one, the quantum event happens, the machine fires, and all complex life is wiped from the planet. In the other branch, the event does not occur, the machine remains silent, and humanity lives on. Now apply the same first-person logic from before, but now to the collective consciousness of our species. In the branch where extinction occurs, there are no human minds left to experience that outcome. All awareness of that timeline ceases from a human perspective. But in the branch where survival occurs, billions of people wake up the next morning, completely unaware of the catastrophic timeline that split away from their own. They simply continue living. From the internal, subjective viewpoint of humanity's continuing consciousness, the species will always find itself in a timeline where it narrowly avoided that particular doomsday. Now expand this thought to every potential existential risk: a killer asteroid on a perfect collision course, a supervolcanic eruption, a deadly gamma ray burst from a nearby star, even a self-created disaster like a runaway artificial intelligence or a particle accelerator accident that unravels space-time. For each of these potential extinction events, the many worlds interpretation suggests the same thing. At the moment of the catastrophe, the universe splits. In some branches, the disaster unfolds as feared, but in at least one branch, through some miraculous quantum fluctuation, a last-minute deflection, or an unforeseen failure of the doomsday device, a remnant survives. And it is only in those surviving branches that conscious observers remain to ask what happened. This creates a staggering statistical illusion for any intelligent species. From its own perspective, it will appear to be preternaturally lucky, surviving against impossible odds time and again. It will always find itself in the timelines where the bullets, cosmic or self-made, miraculously miss. This leads to a shocking and almost philosophical conclusion, a form of Darwinian natural selection operating not on life, but on entire universes. It is known as the anthropic principle applied to quantum branches. Universes that wipe out their observers simply stop being observed. The only universes that have intelligent beings within them to study their own history are, by definition, the ones that did not succumb to early extinction. The multiverse, in this view, becomes a silent graveyard of dead timelines, branches where life flickered out, surrounding the few vibrant branches where consciousness persists. We are not in a special universe because it was designed for us. We are in this universe because it is one of the subset that allowed beings like us to exist and look around. The quantum suicide extension adds a brutal filter to that idea. We are not just in a universe that allowed life to begin. We are in a timeline out of countless doomed ones where every single global catastrophe so far has been avoided. It suggests our continued existence is less a miracle and more a statistical inevitability from our own point of view. The haunting question it leaves us with is not about our past luck, but about our future. Does this logic guarantee our survival forever? Not necessarily. It only guarantees that if there is any possible branching path, however improbable, where a conscious remnant of humanity persists, then some version of us will always find ourselves on that path. The ultimate extinction would require a threat with a 100% probability of leaving zero survivors across all quantum branches, a scenario that is difficult to even conceive. So we press on in this timeline, perhaps not because we are blessed, but because in the silent echoes of the multiverse, the versions of us who were not so lucky are simply no longer here to tell the tale. This relentless branching towards survival creates a strange sense of cosmic purpose, but what if that purpose is an illusion and our very existence is nothing but a fleeting accident? The Boltzmann brain paradox presents a terrifying possibility that emerges directly from the laws of thermodynamics and the concept of an eternal, infinite multiverse. It begins with a simple, unsettling fact about our universe. We live in a state of incredible order. The galaxies are structured, planets orbit stars, and life builds complex, organized systems. According to the second law of thermodynamics, the natural tendency of the cosmos is toward disorder or entropy. A scrambled egg does not spontaneously unscramble itself. So how did we get all this magnificent order in the first place? The standard answer is the Big Bang, which started the universe in an incredibly low entropy, ordered state, and we are still riding the long, slow wave of its disintegration into chaos. But in an eternal and infinite reality where anything that can happen will happen given enough time, randomness gets the final say. Given an eternity, random quantum fluctuations in the void can, by pure chance, assemble anything. It is infinitely more likely for those random fluctuations to produce a single, brief, and fully self-aware brain, complete with false memories of a past and a hallucinated external world, than to produce the entire 13.8 billion-year history of an ordered cosmos. This phantom self-awareness is what physicists call a Boltzmann brain. Think of it like this. Imagine trying to assemble a perfect sandcastle by throwing a bucket of sand into the air. The odds of it landing as a detailed castle are astronomically small, but the odds of a single perfect grain of sand landing upright are much, much higher. In the cosmic lottery of random assembly, a single conscious moment is that one upright grain of sand, while our entire universe is the sandcastle. The shocking, almost unbearable conclusion of this paradox is that if the multiverse is eternal and random, then entities like Boltzmann brains should outnumber real, evolved beings like us by an unimaginable factor. Therefore, you are statistically far more likely to be a Boltzmann brain, a momentary glitch in the void experiencing a phantom life, than a real person in a long-lived, ordered universe. This casts everything into doubt: your memory of waking up this morning, the device you are using right now, the very words you are hearing. All of it could be a detailed, coherent hallucination fabricated in an instant, destined to dissolve back into chaos a moment later. The external world you trust may not be external at all. The paradox is a profound attack on the reliability of our observations. If we cannot trust that our memories and senses reflect a real, consistent past, then all of science, and even our most basic sense of self, crumbles into uncertainty. Are we the result of a grand cosmological story, or are we just the static hiss of eternity, briefly mistaken for a song? Most physicists see the Boltzmann brane as a serious problem for certain models of an eternal multiverse, a clue that our best theories might be missing a crucial piece. It serves as a terrifying reminder that in an infinite sea of possibility, the most likely truth might be the one we find most unsettling. The chilling possibility of being a fleeting accident in the void makes our ordered reality seem impossibly fragile. Yet that very order, the delicate balance that allows us to exist, is itself one of the greatest mysteries in all of science. It is called the fine-tuning problem. The fundamental constants of nature, the unchanging numbers that govern the strength of gravity, the power of the nuclear forces, and the mass of particles like electrons, appear to be set with unimaginable precision. If any one of these values were altered by even a tiny fraction, the universe as we know it would not exist. A slightly stronger gravitational constant, and stars would burn through their fuel in millions of years instead of billions, collapsing before life could evolve. A slightly weaker force holding atomic nuclei together, and hydrogen would never fuse into helium, stars would never ignite at all. The cosmos would be a dark, sterile soup of simple particles. The odds of randomly landing on this specific, life-permitting combination of numbers are astronomically small, like a dart hitting a bull's eye the size of a single atom on the other side of the observable universe. For decades, this staggering precision has begged for an explanation. Some have seen it as evidence of a cosmic designer, but within the framework of the multiverse, a far more natural, if humbling, answer emerges. If the inflationary or string theory landscape is real, then there is not one universe with one set of constants. There are an infinite number of universes, each born with its own random, unique combination of physical laws and numbers. In this infinite cosmic lottery, every possible set of constants is tried. The overwhelming majority of these universes are stillborn or barren. They are the losing tickets. Universes where gravity is too strong and immediately recollapses into a black hole. Universes where electromagnetism is too weak to form stable atoms. Universes that are nothing but empty, expanding darkness. But in an infinite multiverse, even the most improbable outcome must happen somewhere. By the sheer, relentless force of infinite chance, a tiny, tiny fraction of universes will, by random luck, have the exact right numbers for complexity, chemistry, and life. Our universe is not special because it was chosen. It is simply one of those rare habitable islands in an endless sea of cosmic failure. This idea is encapsulated in a powerful concept known as the anthropic principle. In its simplest form, it states that we should not be surprised to observe a universe that is compatible with our existence. We could not possibly find ourselves in a universe that does not allow for observers. Our very presence acts as a filter, selecting for the kind of cosmos that can produce us. The shocking implication is that the apparent design, the breathtaking fine-tuning we marvel at, is an illusion born of a profound selection bias. We are not looking at a universe engineered for life. We are life, looking out from within the only kind of universe we could ever inhabit. The multiverse transforms the fine-tuning problem from a question of why into a question of where. We are not the purpose of creation. We are the fortunate, perhaps inevitable, inhabitants of one winning ticket in an infinite cosmic drawing where nearly every other ticket is a blank. The fine-tuning of our universe suggests a cosmic lottery of infinite possibilities. But what if the true lottery is not happening out in the cosmos, but inside your own skull? This brings us to a theory that is often confused with the many worlds interpretation, yet offers a radically different and deeply personal vision of reality. It is called the many minds interpretation. While the many worlds theory states the entire universe splits into separate physical branches, the many minds theory proposes something far more intimate. The external world, the universe of stars and atoms, remains singular and unchanged. It is your consciousness that does the branching. Think of it like this. In the classic cat experiment, the universe does not split into one with a live cat and one with a dead cat. Instead, there is only one box, one cat, and one quantum event that resolves into a single, definite outcome. However, at the moment you open the box to look, your own mind fractures. One stream of your consciousness perceives the cat alive, purring in the corner. Another completely separate stream of your consciousness, generated in that same instant, perceives the cat lying still. Both streams are real, both are you, but they are now forever isolated from each other, each experiencing a different version of the same objective reality. The shocking twist here is that the universe is not a hall of mirrors reflecting endless possibilities. It is a single solid stage, but the audience, your conscious self, is being endlessly duplicated, with each copy watching a different performance of the same play. Every quantum event you witness, from the decay of an atom to the path of a photon, becomes a fork in the road of your subjective experience. With each observation, you are not walking down one path and leaving another behind. You are splitting into multiple observers, all of whom continue to inhabit the same physical world, but are locked in private, subjective bubbles. This means the person sitting next to you could, in a very real sense, be experiencing a different present moment than you are. Your shared physical reality is constant, but your conscious impressions of it are perpetually diverging. You might see a traffic light turn green, while another stream of your consciousness, branching from the same core you a millisecond ago, sees it stay red and experiences a completely different commute. Both experiences are equally real to the you having them, yet they unfold in the same city, on the same street. The profound and somewhat lonely implication is that we are all alone together. We share a common physical world, but our subjective journeys through it are endlessly forking, creating a private multiverse of experience contained within each skull. You are not one self moving through a branching cosmos. You are a cascade of selves, a chorus of perspectives, all born from a single source and all navigating the same objective reality, yet forever isolated in their own unique bubbles of perception. The loneliness of a private multiverse of mind is one thing, but what if you could step outside your own timeline entirely and walk among the branches? This brings us to one of the most tantalizing and narrative-rich ideas in all of speculative science, the theory of time travel, parallel universes. For generations, time travel to the past has been plagued by devastating paradoxes. The classic example is the grandfather paradox. If you go back in time and prevent your own grandfather from meeting your grandmother, you would never be born, which means you could never go back in time to stop the meeting in the first place. It is a logical knot that seems to forbid backward time travel entirely, but there is a stunningly elegant solution that not only unties the knot, but weaves a new fabric of reality. The solution is this: you cannot change your own past because you never actually visit it. When you activate a machine to travel backward, you are not moving along the single thread of history you came from. Instead, you are jumping sideways, departing your original timeline completely and arriving in a brand new parallel universe that is a near-perfect copy of your past, frozen at the moment you arrive. In this new branch reality, you are now a visitor from another world. Your actions are not erasing history, they are creating it. If you were to intervene and alter a major event, you would simply be writing the first draft of history for this new, separate cosmos. Your original timeline remains untouched, playing out exactly as you remember it, with no memory of your departure. The version of your grandparents there meet, fall in love, and your ancestors are born, completely unaffected by your actions in this other reality. This model, often called the alternate histories or branching timelines model, turns time travel from a paradox generator into a universe generator. Every journey to the past is a one-way ticket to a new, nearly identical parallel world. The shocking physical implication is that backward time travel, if it is ever possible, might not be navigation at all. It might be creation. The act of attempting to move against the arrow of time in your own universe could be fundamentally impossible, like trying to swim upstream in a river that flows in only one direction. But what if the universe offers a different current? The physics could work such that the immense energies required to warp spacetime backward simply pinch off a new baby universe from the historical point you are targeting. You do not travel into yesterday, you give birth to a new tomorrow that looks exactly like yesterday. This means you could never truly go home, you could never return to the exact universe you left because your departure point is now forever ahead of you in a timeline you are no longer part of. You might find a universe that seems identical in every detail, but it will be a different branch, a different layer of the multiverse. The people in it would have memories of a past where you never appeared because in their history you did not. You would be a ghost from a world that to them never existed. This theory liberates time travel from its logical chains and opens a universe of narrative possibility, which is why it is so beloved in fiction. It is the engine behind stories where heroes try to fix the past, only to discover they have created an entirely new, often worse, present that they are now stuck in. But beyond fiction, it presents a profound philosophical stance on the nature of reality. It suggests that the past is not a fragile, editable record. It is a solid, immutable fact within its own timeline. The multiverse protects history from paradox by providing an infinite canvas for new stories. Every what if is not a question about our past, but a blueprint for another world's present. So if you ever dream of stepping into a time machine, be prepared for farewell, not a reunion. You would not be rewriting your story. You will be starting a completely new book on a shelf in a cosmic library you can never leave. The world you see is a lie. It is a useful, convincing, and necessary lie, but a lie nonetheless. This is the startling claim of cognitive scientist Donald Hoffman and his theory of conscious realism. He begins with a simple evolutionary question: why do we perceive the world the way we do? The answer is not to see truth, but to survive. Evolution sculpted our senses not to reveal objective reality, but to hide it, providing us with a simplified, symbolic user interface. Think of the desktop on your computer. You see folders, files, and a trash can. You do not see the actual, mind-boggling complexity of magnetic domains on a hard drive or quantum states in a processor. That raw reality is useless to you. The icons are a fiction, but a fiction that allows you to navigate, to click, and to get things done. Hoffman argues our perception of space-time, of solid objects, of colors and sounds, is exactly that, a desktop of icons. A three-dimensional space with objects moving through time is not the fundamental fabric of the cosmos. It is our species-specific interface, designed over millions of years to help us find food, avoid predators, and raise offspring. The shocking implication is that the physical universe, as described by physics, is not the bedrock of existence. It is the rendered graphics of our perceptual software. So what lies beneath the interface? Hoffman proposes a reality far stranger, a vast dynamic network of what he calls conscious agents. In this view, consciousness is not a product of the brain. It is fundamental, the primary substance of existence. Matter, energy, and space-time are its derivatives, its symbols. The true cosmos is a web of these conscious entities interacting with each other in ways we cannot directly perceive, communicating through the symbolic language of our shared interface. This is where the theory explodes into a multiverse of a deeply personal kind. If reality is constructed by consciousness, and each conscious agent has its own perceptual apparatus shaped by its own evolutionary history, then we are not all looking at the same stage. We are each running a slightly different version of the simulation. Your user interface and mine are similar enough that we can agree on the location of a chair or the color of a traffic light, but they are not identical. The raw data, the true reality we are both interfacing with, remains hidden and may be interpreted differently by our separate systems. In a very literal sense, you and I are living in adjacent, overlapping, but distinct parallel universes, reality tunnels carved out by our own consciousness. A dog with its powerful sense of smell navigates a world rich with chemical information that is just a blank icon on our desktop. A bat perceives the world through sonar, constructing a reality of echoes we are deaf to. Hoffman suggests we are all like that, blind to the true nature of things, inhabiting a personalized universe built for our survival. The most profound shock here is the death of objective physical reality. There is no single shared external world out there waiting to be discovered. There is only the infinite dance of conscious agents and the private parallel worlds they each construct in order to interact. Your universe is yours alone, a bespoke creation of your consciousness, and you are forever trapped behind its beautiful, illusory icons. Gravity may not be the master architect of the cosmos after all. A radical alternative challenges the very foundations of modern cosmology, proposing a universe woven not by gravity's slow pull, but by the swift, fierce crackle of electricity. This is the plasma universe or electric universe cosmology. Its proponents argue that for too long we have been telling a one-sided story, fixated on gravity while ignoring the dominant force in our observable universe, electromagnetism. In this view, the vast swirling arms of galaxies are not held together by invisible dark matter, but by immense flowing currents of electricity coursing through the sea of space plasma. Stars are not isolated nuclear furnaces powered by gravity alone, but rather glowing nodes in a cosmic circuit, their brilliance and behavior shaped by the electrical energy they draw from their galactic environment. It is a vision of a living, dynamic, and electrically connected cosmos. Now extend this electrifying idea to its ultimate scale. If our universe is a single brilliant pattern of discharge within an infinite, electrically conductive medium, then what else might that medium contain? The theory suggests a multiverse of staggering elegance. Picture the cosmos not as a collection of separate bubbles, but as an eternal fractal lightning storm. Our entire observable universe, with all its galaxies and stars, could be just one brilliant flash, one luminous filament within a boundless supergalactic circuit. Other flashes, other filaments would be other universes. They might operate under slightly different electrical properties, leading to different physical constants and structures, but they would all be part of the same infinite electrical network. This transforms the multiverse from a set of disconnected realms into an interconnected web, a cosmic neural network of flowing energy. The most shocking implication is one of direct physical connection. In the gravity-dominated view, other universes are forever sealed off behind dimensional walls or cosmic horizons, but in an electric multiverse, the connections might be tangible. The colossal plasma filaments that some astronomers observe connecting galaxy clusters over hundreds of millions of light years might not end at the edge of our vision. They could be the cosmic power lines, the transmission cables, linking our local galactic neighborhood to other, unimaginable discharge regions far beyond our observational reach. Celestial bodies we see as isolated islands might actually be terminals in a circuit of unimaginable scale. This offers a profound and haunting possibility. The strange high-energy phenomena we struggle to explain, like the mysterious fast radio bursts that ping our telescopes from the deep void, might not be cosmic accidents. They could be signals, or perhaps simply the background static of a universe talking to itself along wires of plasma, a faint echo of the unimaginable traffic flowing through the multiversal grid. The cosmic grid of plasma suggests a universe humming with energy, but what if that hum is not just random static? What if it is the sound of the cosmos thinking? This leads us to a theory where reality is not a storm of electricity, but an unimaginably vast machine processing the ultimate equation. This is the idea of the universe as a quantum computer, championed by physicist Seth Lloyd. He proposes a radical shift in perspective. Forget galaxies and particles as the fundamental stuff of existence. Instead, consider the most basic unit of reality to be a bit of information. In this view, every single interaction in the cosmos, from the collision of two atoms to the fusion of a star, is not merely a physical event, it is a computational operation. Each particle is a qubit, the basic unit of quantum information, and every time they interact, they form a quantum logic gate, processing that information in a fleeting, elemental calculation. The universe from the Big Bang to this very moment is not just expanding and cooling, it is computing. It is running a program of unimaginable complexity, with the laws of physics acting as its immutable code. The shocking implication of this computational cosmos is a new vision of the multiverse. In a classical computer, a problem is solved by following one sequence of logic steps. But a quantum computer leverages superposition, the ability to be in multiple states at once, to explore many possible solutions simultaneously. Apply this principle to the universe itself. The cosmic quantum computer does not calculate a single linear history. To find a solution, whatever that ultimate solution may be, it must explore all possible computational paths at the same time. Every quantum choice, every fork in the road of possibility, represents the computer testing a different branch of its cosmic algorithm. This means our entire timeline, our history from the first hydrogen atom to the civilization listening now, is not the only calculation. It is one thread of execution in a processor of godlike scale. Parallel universes in this framework are not separate bubbles or distant branes. They are the other computational threads being explored in superposition. There are the alternate calculations the universe is running in parallel, testing every possible variable, every permutation of physical law and historical event, in its relentless drive to solve a problem whose nature we cannot begin to fathom. Our reality is one output among an infinite number of possible outputs. The purpose of existence, then, might not be to exist for its own sake, but to process information. We are not passive inhabitants of a random cosmos. We are active patterns within a computation, and every thought you have, every observation you make, might be part of the data stream. This transforms the meaning of everything. The stars are not just burning balls of gas, they are processing nodes in a galactic cluster. Your consciousness is not an emergent property of biology, but a localized and complex pattern of information being processed by the universal machine. The haunting question this theory leaves us with is profound. If the universe is a computer, who or what wrote the program, and what is it trying to figure out? But if the universe is a computer, who is the programmer? Perhaps the answer is not a who but a what, and it is closer than we think. The 21st theory turns the entire cosmic hierarchy upside down. It is called biocentrism, proposed by scientist Robert Lanza, and it begins with a simple, revolutionary declaration: consciousness does not arise from the universe. The universe arises from consciousness. We have been looking at the map backward. Biology is not a minor passenger on a physics-driven ship. Biology, through the lens of conscious observation, is the captain, and physics is the ocean it sails upon. In this view, space and time are not the fundamental containers of reality. They are the tools, the very language that our minds use to organize and make sense of the sensory data flowing into us. Think of them not as external realities, but as the software of perception, a biological user interface for navigating a world of potential. Without a living observer to process events into a sequence, there is no past, present, or future. Without a mind to relate objects, there is no here or there. The universe requires a perceiver to collapse from a fog of possibilities into the solid, spatio-temporal world we experience. This leads to a multiverse of a deeply personal and immediate kind. The observed world is utterly relative to the observer. An animal, a human, and an alien do not merely interpret the same world differently. They each literally inhabit a different perception-created universe. A bat navigates a reality constructed from sonar echoes, a world of precise acoustic shapes we are blind to. A bee sees in ultraviolet patterns on flowers, a secret landscape of guiding lights. These are not just different views of one stage, they are different stages entirely, built by the unique sensory and cognitive apparatus of the observer. The tree falling in the forest with no one around does not make a sound, because sound is an interpretation of air pressure waves by a conscious auditory system. Without that system, there are only vibrating molecules in a field of potential. This means you are not just in a universe, you are actively constructing the one you are in, moment by moment, through the act of perception. The shocking extension of this idea concerns the one experience every conscious being fears the most: death. Biocentrism proposes that death as we understand it is an illusion. If consciousness is the fundamental reality and space and time are merely its tools, then when the biological body ceases to function, those tools are simply set aside. The individual consciousness, the perceiving self, does not end. It exists in a timeless, spaceless multiverse of possibilities. What we call a lifetime is just one particular window, one specific channel that our biological senses are currently tuned to. It is like watching a single movie on a television. When the movie ends, the screen does not vanish. The consciousness that was watching simply shifts its attention. It may tune to another channel, another possibility within the infinite landscape of existence. In this view, the linear narrative of birth, life, and death is a story we tell ourselves within the framework of time, a framework that itself is a product of the mind. From outside that framework, all possibilities exist simultaneously. the version of you that is 10 years old, the version making a different choice yesterday, and the version that exists in a world where history unfolded another way, all are equally present in a state of potential, waiting for an observer to bring them into focus. This does not promise a traditional afterlife of pearly gates or reincarnation into another body on Earth. It suggests something far more profound and strange. Your consciousness is eternal not because it travels through time, but because it exists outside of time. Death is not an exit, it is merely the end of one particular perspective, after which the perceiving self continues in a realm where all stories are equally real and all moments are now. You are not a fleeting visitor in a cold, physical cosmos. You are the center of your own creation, and the show never truly ends, it only changes the scene. The serene image of a black hole as a one-way door to another reality hides a violent secret. Deep within the theoretical physics community, a battle rages over what truly happens at the point of no return, the event horizon. For decades, the accepted wisdom was elegant and strange. An astronaut falling into a large black hole would feel nothing special as they crossed the horizon. They would be peacefully, if inevitably, pulled toward the crushing singularity at the center. This principle, called the no-drama postulate, was a cornerstone of general relativity. But a few years ago, a group of physicists dropped a bombshell. They argued that to preserve the fundamental laws of quantum mechanics, the event horizon could not be a placid place. Instead, it must be a raging inferno, a searing wall of unimaginably high-energy particles. They called this the firewall paradox. The firewall is not a solid wall of rock, but a region of space so violently energetic that any matter crossing it will be instantly and completely vaporized, reduced to its most fundamental information. The existence of such a firewall solves one set of quantum problems, but creates a catastrophic conflict with Einstein's theory of gravity, which insists the horizon is uneventful. This paradox has forced physicists to propose even stranger resolutions, and one of them offers a shocking new vision for how parallel universes are born. Some theories now suggest the firewall is not a place of destruction, but a place of duplication. It is a cosmic photocopier of the most extreme kind. Imagine our brave or perhaps foolish astronaut approaching the black hole. As she reaches the event horizon, the intense quantum forces do not destroy her. Instead, they split her reality. In one branch of space-time, she encounters the firewall. Her physical form is incinerated, transformed into a burst of energy and information that smears across the horizon. But in that very same instant, the information that defines her, the exact quantum state of every particle in her body, is not lost. It is faithfully transmitted across the boundary. A perfect self-aware copy of the astronaut continues her fall, unharmed, into the interior of the black hole, experiencing the no-drama journey general relativity promises. From her perspective, she simply falls inward. From an outside observer's perspective, she was burned to ash at the horizon. Both perspectives are correct within their own reference frame. The firewall in this view is not a physical barrier, but a marker of a fundamental split in the fabric of reality itself. It is the line where one universe becomes two. The astronaut is not killed, she is forked. One version ends in fire, the other continues into the unknown depths. Now take this microscopic personal event and scale it up to a cosmic magnitude. If the immense gravitational extremes at a black hole horizon can trigger a space-time split, could other titanic events in the universe do the same? Perhaps the birth of a galaxy, the collision of neutron stars, or even the Big Bang itself were not singular events, but moments of cosmic forking. At each of these cataclysms, the fabric of reality, strained beyond its limits, may have torn and healed by creating a duplicate. One universe continues down one path of cause and effect, while a new parallel universe branches off to follow another. This is a multiverse generated not by tiny quantum choices, but by the thunderous, macroscopic drama of the cosmos itself. Every star that goes supernova could, in its final furious seconds, give birth to a twin reality. The universe we see is not a single linear history, but the survivor of an endless series of cosmic splits, a branch that kept growing while countless others sprouted in directions we can never see. The firewall paradox began as a crisis for physicists, but its resolution may reveal a universe that duplicates itself at every major juncture, ensuring that no story, no matter how cataclysmic, ever truly has only one ending. The violent duplication at a black hole's edge suggests a cosmos that splits under pressure, but what if the greatest pressure of all, the Big Bang itself, never actually happened? There is a theory that erases the moment of creation entirely, replacing it with a gentle cosmic rebound. This is loop quantum cosmology, a vision that emerges from the quest to marry quantum mechanics with gravity. It proposes that space itself is not a smooth, continuous fabric, but is woven from tiny, indivisible loops, a fabric of space-time quanta. This has a breathtaking consequence for the beginning of everything. In Einstein's theory, rewinding the expansion of the universe leads you back to a singularity, a point of infinite density where all known laws of physics break down. It is the ultimate dead end for science, but in loop quantum cosmology, those fundamental loops of space resist being crushed beyond a certain point. They create a repulsive force that grows stronger as density increases, so instead of collapsing into an infinitely small, hot point, the universe in a previous contracting phase reaches a maximum density and then bounces. The Big Bang was not a beginning from nothing, it was a big bounce from a prior universe that had been collapsing. Our expanding cosmos is simply the aftermath of that rebound. This gives us a cyclical model of breathtaking scale, a universe that breathes in and out over trillions of years, but here is where the multiverse quietly unfolds. While the bounce itself may be smooth, the universe is never perfectly uniform. Tiny quantum fluctuations, the same kind that seeded galaxies in our own timeline, are present in the contracting phase. When the bounce happens, these random jitters are not erased. They are imprinted onto the new expanding universe as it is born. They become the blueprint for its large-scale structure. Now imagine this cycle repeating, not just once or twice, but for an eternity. Each bounce resets the cosmic clock, but it does not produce an identical copy. The quantum fluctuations from the previous contraction ensure that every new cycle is unique. The physical constants, the number of dimensions that stabilize, the very strength of the forces, could all vary slightly from one cosmic iteration to the next. Over an infinite number of cycles, every single possible combination of physical laws and initial conditions will be realized. This creates a sequential multiverse, a chain of universes linked through time by an endless rhythm of collapse and rebirth. Our universe is not a solitary bubble in an inflationary foam. We are simply the current cycle in an infinite series. The version of reality we experience, with its specific particles and forces, is just one page in a book that has been written and rewritten forever. Somewhere in the distant past, a previous cycle may have had 5 stable spatial dimensions. Somewhere in the far future, a subsequent bounce may produce a universe where electromagnetism is 1,000 times stronger, making chemistry impossibly fast and violent. We exist in this particular cycle because its parameters allow for stars, planets, and curious minds to form. The loop quantum bounce transforms the multiverse from a sprawling, simultaneous landscape into a profound historical procession. We are not adjacent to other worlds in space, we are preceded and succeeded by them in time, each one a variation on a theme, echoing through an eternity of cosmic breaths. The universe may breathe in cycles of physics, but our own minds breathe in cycles of myth and dream. This brings us to a theory that blurs the line between the cosmos and the psyche, a collaboration between two of the 20th century's greatest thinkers. On one side, the physicist Wolfgang Pauli, a pioneer of quantum mechanics who helped uncover the bizarre rules of the subatomic world. On the other, the psychologist Carl Jung, who mapped the depths of the human unconscious. Together, they explored a strange territory where physics and psychology seemed to converge, a realm they called the psychoid. Their work suggests that the archetypes and symbols surfacing in our dreams and myths are not just personal fantasies. They could be access points to parallel realities of pure meaning, worlds that shape our own from a deeper dimension. Jung proposed the idea of a collective unconscious, a shared psychic layer beneath our personal minds. He believed this layer was populated by universal archetypes, primal patterns like the hero, the mother, the trickster, or the shadow. These are not specific images, but deep templates that shape our stories, our art, and our understanding of the world. Pauli, having witnessed the probabilistic observer-influenced reality of quantum physics, was fascinated by how these inner patterns seem to manifest in the outer world through meaningful coincidences, which Jung termed synchronicities. A synchronicity is not mere chance, it is an event in the physical world that feels deeply connected to an inner psychological state, like dreaming of a rare bird and then encountering it the next day, or thinking of an old friend just as they call. For Jung and Pauli, these were not flukes, they were glimpses of a psychoid reality, a foundational layer where mind and matter are not yet separate, where the inner world of meaning and the outer world of fact are fused into one substance. This leads to a shocking extrapolation. What if the archetypes of the collective unconscious are not just psychological concepts, but are themselves doorways? Each archetype could be a living, dynamic parallel universe of pure potentiality and narrative logic. The hero's world is a reality governed by the laws of quest, sacrifice, and transformation. The mother's world is a dimension defined by creation, nurture, and primal connection. These are not physical places with stars and planets, they are realms of pure pattern and meaning, operating just beneath the surface of our own. When we dream or when we are gripped by a powerful myth, our consciousness might be briefly tuning into these archetypal frequencies. We are not creating the story, we are visiting it. A profound synchronicity, then, might be a moment when this underlying psychoid reality briefly bulges into our physical timeline, creating a resonant echo between an inner archetypal pattern and an outer event. The universe seems to be speaking in symbols because, at this fundamental level, it is symbolic. This theory proposes that our physical cosmos is not the primary reality. It is a projection, a crystallization from this deeper realm of archetypal worlds. The laws of physics we measure could be the hardened, quantitative shadows of these qualitative, living patterns. The Big Bang might be the physical expression of a primordial archetype of emergence, while the structure of an atom could reflect an archetype of relationship and binding force. The shocking idea is that our science and our myths are describing the same reality, just from different angles. Physics probes the external, measurable shell. Psychology and spirituality probe the internal, meaningful core, and in the psychoid layer they are the same thing. This means that every time you feel a myth resonate deeply or experience a dream of profound symbolic power, you might be brushing against the architecture of a parallel world, one that is constantly weaving the tapestry of meaning from which our own universe is spun. The archetypal worlds of the psyche and the mathematical structures of physics may seem galaxies apart, but they could be different languages describing the same ultimate library. To make sense of this overwhelming cosmic catalog, physicist Max Tegmark proposed a staggering hierarchy, a classification of all possible multiverses into 4 distinct levels. Revisiting this framework now after our long journey brings a profound clarity. It reveals a nested reality where each deeper level contains the one before it, culminating in a final theory so absolute it borders on the philosophical. Level 1 is the simplest, born from pure geometry. If space is infinite and matter is roughly evenly distributed, then somewhere far beyond our cosmic horizon, there must be regions identical to our own. Another Earth, another you, living a life nearly indistinguishable from this one, all within the same vast, unending universe. It is a multiverse of mere distance. Level 2 is the realm of eternal inflation, the bubbling cauldron of creation. Here, separate universes are not just far away in our space, but entirely disconnected bubbles of space-time, each with its own random set of physical constants and dimensions. Our cosmos is one hospitable bubble in an infinite frothing sea of possibilities, some sterile, some wildly alien. Level 3 is the domain of quantum branching, the many worlds interpretation. In this view, every quantum decision forces reality to split, creating a near-infinite array of parallel timelines, all equally real, diverging from this moment forward. This is the multiverse of choice and chance, unfolding in a tapestry of endless variation. But then we reach level 4, and here, all concepts of space, time, and quantum probability dissolve into something far more fundamental. This is the ultimate ensemble, the mathematical multiverse. It states that every single mathematical structure that is logically consistent exists as a physical reality. Not just the structures that describe our physics, but all of them. A universe where geometry has 5 stable dimensions exists. A reality where the number pi equals exactly 3 exists. A cosmos built on a system of logic utterly foreign to our own exists. In this final, all-encompassing level, the other 3 are merely subsets, the infinite spaces of level 1, the inflationary bubbles of level 2, and the quantum branches of level 3 are all specific, self-consistent mathematical structures. There are individual books in an infinite, immutable library. The truly shocking finale of this idea is its brutal simplicity. There is no why for our universe's particular laws, no fine-tuning by a designer or random selection in a cosmic lottery. We do not exist because these laws are special. We exist because we are self-aware patterns within one specific mathematical structure that allows for such complexity. We are simply in this one, and we call its rules physics. Every other possible set of rules, every other coherent reality you can or cannot conceive of is out there, equally real in a state of timeless being. The ultimate ensemble does not explain our universe. It swallows it whole, placing our entire story and every other story imaginable on a shelf in a silent, eternal library of all that can be. From quantum cats to cosmic collisions, from simulated worlds to the silent library of mathematics, we have ventured across 25 breathtaking frontiers of thought. Each theory, from the branching of many worlds to the holographic projection of reality, from the cyclical rebirth of the ekpyrotic universe to the personal multiverse of your own mind, represents a profound attempt to answer the oldest questions. What is real? Where are we? And why is there something rather than nothing? While these ideas remain at the speculative edge of physics and philosophy, they are not mere fantasy. They are the straining of the human intellect against the boundaries of the observable, the logical extensions of our most trusted equations, and our deepest intuitions. They remind us that our universe, for all its vastness and majesty, might be a single note in an infinite symphony, one thread in a tapestry woven from possibilities. So we are left with a final personal mystery, one that echoes back through every theory we have explored. In which of these infinite realities do you think this version of you exists? Are you the inevitable product of a finely tuned bubble, a ghost in a cosmic simulation, a conscious agent constructing your world, or a mathematical pattern awakening to itself? The journey does not end here. Tell us in the comments below which theories shocked you the most, or share your own vision of the multiverse. If this exploration expanded your reality, please like this video and subscribe for more journeys to the edge of understanding. Thank you for watching, and never stop questioning the nature of your own existence.